Let's talk about how much money you're gonna be paying for your clothes a few years from now. Let's see if you can see the board. Yeah, it should be good. All right, let me show you what I'm talking about. So it says in 1985, the cost of clothing for a certain family was $620. In 1995, 10 years later, the cost of clothing for this family was $1,000. Assuming the cost increased linearly, what was the cost of this family's clothing in 1991? So, basically what they tell us is, the price to buy clothes to put on this family, every year you need a little bit more money to buy clothes. So the relation to give us is starting somewhere at $620 in 1985. So what happened? It increases linearly. That's what they tell us. Increases linearly. It could be a little bit, steeper or a little bit more flat, but it increases linearly. That's the point they tell us. But they say right here in 1995, 10 years later, the cost. How much it costs to buy clothes? $1,000 to buy clothes for the same family. Now, what they want to know is, right here, somewhere here after the middle, 6 years later, 6 years into it, in 1991, how much did it cost for this family to buy clothes? So, folks, the problem here is very simple. So what they want to know is basically, okay, if I was buying clothes at $620 in 1985, and in 1995, 10 years later, my clothes cost $10,000. And between that, if I don't remember, if I want to go back and say, hey, in between that, in 1991, how much I paid for clothes? So that's what we're going to solve for here. Like they say, the key here is they say it increases linearly. So let's play with what they give us. They say 620 plus 10 years of increase, 10 years from 1985 to 1999. So we're going to find a relation between that 620 and that 1,000. So we're going to say what happened to that 620, make it 1,000 all of a sudden 10 years later. So I started with 620, 10 years into it, times a number X, which is the rate at which that stuff increased, the rate at which. So that means every year, how much more money I got to put into buying clothes. So times 10 years. So the reason why we would put 10 is because between 1985 and 1999, that's how many years elapsed. If we were doing it if they give us that information for 1986, we would say 1x. So times 10 years times 10x is equal to 1,000. So what we're doing here, 10x, we're gonna move this guy to the other side, so we're gonna have 1,000. We change sign here, 620. Let's see if you can still see on the board here. Let's see, not really. All right, times 620. I gotta make sure I use this efficiently. So we can come out here and say 10x is equal to 1,000 minus 620. I'm gonna need a calculator. Minus 620, 380, and that implies x equals 380 divided by 10. Let's see if you can still see that thing. A little bit. That means that implies x is equal to 38. Okay, so now we have x equal to 38. So we're gonna replace x in this equation, right? Okay. So we know we're starting at 620 plus x times, how many years is between 1985 and 1991? How many years is that? 86, 87, 88, 89, 90, 91. That's 6 years, right? Times 6, that's equal to what? That's equal to That's what they're asking for. But what x? We already found x, right? X is equal to 38. So 620 plus 38 times 6 is equal to what we're looking for. So 620 plus 38 times 6 is equal to 848. So basically, to wrap it up, basically what we're doing here is because they tell us it's linear, so we start in with how many years, how many we had in the first year, in the starting year, and then we add how many years it increased by times a certain rate factor. That's the rate at which it increases. So that means every year how much more I have to put into my account to be able to buy clothes. So that's what this x says here. So it's the same thing we did here. 620 times 10, x is equal to 1,000 because there's 10 years difference between 1985 and 1999. Same thing here. 620 times 6, x is equal to whatever we're looking for because there is 6 years of difference between 1985 and 1991, and you can count for those. Thank you very much. And if you enjoyed this video, share it on your page. You'll enjoy a lot of kids taking the ACT and the SAT exam. Thank you very much. Bye.